In this video, we'll introduce the idea of finite geometric sequences. Finite geometric sequences start with an initial value or initial term a. And the second term can be found using a multiplied by a common ratio r. And the next term can be found using the previous term ar multiplied by the common ratio to get ar squared. So every term in a finite geometric sequence can be multiplied by the common ratio to get to the next term. And eventually, we'll get to the last term of the sequence ar to the n minus 1, where n is the number of terms in the sequence. So a sequence starts with the first term a, second term ar, third term ar squared, and the last term ar to the n minus 1. For an example, if a sequence starts with 0.05 and the next term equals to 0.05 times 2, which means maybe the common ratio is 2 and the initial term is 0.05. And if the third term is 0.05 times 2 squared, which means that's the third term of a finite geometric sequence, and the last term of the sequence supposedly to be 0.05 times 2 raised to n minus 1, and if there's 30 terms in the sequence, then you can replace 30 by n by 30, simplify it to be 0.05 to the 29th as the last term of the sequence. It's a good thing about finite geometric sequences is we can find the sum of all the terms in the sequence using an enclosed formula. So if you add all the terms of the sequence together, the sum of all the terms will be equals to a, which is the initial value, initial term, multiplied by a fractions r to the n minus 1 divided by r minus 1, where r is the common ratio and n is the number of terms in the sequence. Cool, huh? So we can actually figure out the sum of all the terms in a geometric sequence, a finite geometric sequence, using this short enclosed formula. The question is why? Why can we use that formula to find the sum of the sequence? Here's a quick proof for that sum formula. Let's start with the generic finite geometric sequence, and we see that a is a common term, so we factor the a out, and 1 plus r squared to r to the n minus 1 are the leftover of each of the term after the factoring step. So let's give it a name, s. So s will be, the value, the sum of all the terms in the sequence. The next step is we are going to multiply this sum by the common ratio r. Okay? So on the right side, we have this expressions multiplied by r. On the left side, it's going to be r times s. So r is a common ratio, s supposedly is the sum of all these terms here. Then on the right side, we will distribute the r into each of the term in this parenthesis to make it r plus r squared plus r cubed plus r to the n multiplied by a. And the left side, it's still just r times s. Now we are going to subtract this sum, right? It's a new sum by the original sums s. And the original sums of the sequence is a times 1 plus r squared to the r to the n minus 1. Now look at the right side. of these subtractions. Again, our a is still the common term, so we factor the a out. And we are to find, so what is left over after subtract these expressions from these expressions? We observe that r minus r is gone, r squared is gone, r cubed is gone, up to r to the n minus 1. And in these expressions, r to the n is the only term that's left. And in these expressions, after the subtractions, 1 is the only term that's left. So then in this parenthesis, we have r to the n minus 1 for the right side of this subtraction. On the left side, rs minus s equals to, we see that s is a common term, so we factor it out. And the leftover is r minus 1. So then at this step, we think about, okay, well, the ultimate goal is to solve for s, right? We want to figure out what is the sum of this sequence. And now at this point, we have these equations. So in order to solve for s, we divide both sides by r minus 1. Get rid of r minus 1 to have s on the left side by itself. And here we go, the right side is the formula of the sum of all the terms in a finite geometric sequence. We already proved this is a good formula to use if we have a finite geometric sequence and we want to find the sum of all the terms. Now let's look at the previous example. Here, a geometric sequence, and we want to figure out, the sum of this sequence, right? This sequence has the initial terms of 0.05, common ratio is 2, and there's 30 terms in the sequence. First, second term, third term, and 30th term. To find the sum of this sequence, which means if we add all the terms of the sequence together, what is going to be? At this point, we know that we can use this formula here in order to find the sum. So we plug in a is 0.05, r is 2, n is 30, and r is 2 into this formula, and we calculate it. It's going to give us 53,687,091.15. So this is the sum of this sequence. As you can see that even though the sequence starts with a very small value, but with the ratio of 2 and the number of terms is 30, the sum of this sequence can be quite large, more than 53 million. Here we go. Here's an example of a finite geometric sequence and how to find the sum of such sequence.